This is a tutorial to flash MESC firmware to an MP2 electronic speed controller. Before I start, I'd like to thank my friends who have done most of the work with developing this firmware and the ESC. We're going to break this up into two videos. The first video is a minimal build needed to compile MESC code to run on an MP2. The steps will include loading MESC into STM32Cube IDE, configuring the code to work for your motor, connecting the pill, flashing the code to that pill. The second video will include starting the STM-Cube debugger, viewing variables coming from the MP2, using the MP2 terminal, and spinning the motor. This video does not cover building an MP2, determining your motor parameters, or a deep discussion on how the MESC firmware operates. That can be found elsewhere. This is a partial list of what you need. You'll need to install the STM32Cube IDE. You'll need a physical device called an ST-Lynx V2, which is very inexpensive, and you'll need an STM32 pill. There are two pills to choose from: the STM32F411 black pill and the STM32F405 open source pill. A link is given for the open source pill. This video is just a guide. I avoid step-by-step tutorials because things like the MESC code is always changing, the STM-Cube IDE interface is likely to change, things vary depending on what operating system you're using, and the pills can be slightly different. One other thing to note before starting: the MESC project, when you import it into STM-Cube IDE, imports everything including the code and the CPU configuration. Don't confuse this with other tutorials that usually walk you through the CPU configuration. That's not needed here. Also note that there are many ways to perform a flash using these different utilities, but the easiest way to perform the compile for the MESC code is with the STM-Cube IDE. Flashing is not going to instantly spin your motor. In fact, I recommend disconnecting your pill altogether for your first flash. Loading MESC into STM-Cube. To get started with loading MESC, let's create a local copy of MESC from the Github site. There's a link in my comments section that takes you to the Github site. Go there and download a zip file. On my computer, it will download and immediately be uncompressed. Importing this code into STM-Cube project can be frustrating. The best way to do this is to start by creating a totally new workspace. Open up the STM32Cube IDE, go to the top level folder, create a new workspace folder. Open that and launch. Hopefully STM-Cube will show import project here, and you can use this import wizard to import an existing project. Find the uncompressed folder, hit next, and you should see a lot of MESC folders here. Hit open, and if everything is working properly, the import projects wizard will show you a bunch of different folders with check marks. Hit finish, and then we go here, and you can see all of the MESC code in the Project Explorer. Hit save here, and then we'll move forward. Now we're going to configure the MESC code to run a motor. This is relatively complicated, but keep in mind we will keep a separate GitHub branch with the exact code changes that are shown here, and we'll include a document that you can use as a cheat sheet. The following is a set of files that you need to edit for a basic MP2 configuration. Notice that for the first file, the include directory is coming from MESC common. The other two files are found in MESC F405RG. Let's take a look at MESC motor defaults in the Project Explorer. As I mentioned, this video will not show you how to physically and electronically determine your motor parameters. There is a document tutorial for finding those numbers in the description section of this video, but for now we're going to assume you already know these numbers and just want to plug them in. This is an example code block that you would want to create and fill in for your motor. It has values for flux linkage, motor inductance, called LQ and LD, motor resistance, pole pairs, phase current, and power. For example, I have a new motor, the top power 128, and these are the variables that I'm going to use for that motor. Now let's look at the MP2-VO_1. This file is used by MESC for MP2 boards. Note that MESC can work for lots of other ESCs, but this is a configuration file for an MP2. These are the variables that you need to touch in this file. ABS max phase current controls the amount of amps that can be dumped into each phase of the controller. ABS max bus voltage and ABS min bus voltage are cutoff values for the battery voltage coming into the controller. Max IQ request refers to how much the user can crank the throttle and requests the controller to deliver amps to the motor. Set this amount to about half of what you use in ABS max phase current. VBus bottom and VBus top refer to values for resistors that are used as voltage dividers to measure phase voltage. Take a look at this section of the MP2 circuit. These resistors may vary between MP2 boards, but in my case, because I have 100K and 3.3 resistors in these dividers, I'm going to use these values.
Note that when you're in this file here, you have to change this to the tag that was in motor parameters. In our case, it was called TP128.
Next, let's look at the MESC F405.h. We need to uncomment this include statement. That's the include file that you just got done editing. Make sure that you've commented out all the other header files. There's nothing else to change in this file, but let me call attention to these two values. ADC1 min and ADC1 max. Your throttle is probably going to be connected to the ADC1 input. This sets the lower and upper limits associated with that throttle. And we're going to return to looking at these values in the next video. Now we're going to connect the ST-Link to your computer and the pill. ST-Links are available from lots of different sources, and there are a lot of tutorials for using them to flash a pill. The idea here is that the ST-Link device is connected to your USB cord, the USB cord is connected to your computer, then these wires go from the ST-Link over to the pill. There's only 4 wires, and they're usually labeled with these names. Once that's connected, you can flash the MESC code. But keep in mind that you may need to restart the STM32 Cube IDE after you have plugged these in order for it to work. Let's flash the MESC code. My pill uses an F405, so let's go to this folder. If I click on one of these files, it will then know what architecture to compile. Hit the build icon. The compilation is running here. You can see it in this window. When that finishes, we can start to flash the pill. Remember, if you're doing this for the first time, do not connect the pill to the MP2. To flash, select the debug configuration file and then press the debug icon. It loads, and there we are. You have flashed your first STM32 pill. In the next tutorial, we'll use the debugger to make sure everything is working and eventually spin the motor.